Welcome to the Intel Network Builders Technology vSummit series. Time now for our session on engaging the Edge developer community with OpenNESS for a faster and optimized development cycle, part of the Network at the Edge vSummit. The emerging Edge environments landing on 5G networks require a new set of cloud-native developer tools that can handle the complexity of highly deterministic and performant network functions, as well as applications built for AI and media. To discuss the challenges of Edge deployments and to tell us more about Intel's OpenNESS Edge Computing Toolkit, I would like to welcome Prakash, Kartha, Segment Director, Edge Services, Network Platforms Group at Intel, and Russel, Callen, Platform Solution Architect with Intel. Hello, both of you. Thanks for joining us today. Prakash, can we start by exploring some of the industry challenges when deploying Edge?
Thank you, Guy, and a great topic again, the topic for today's Edge. And yeah, let's start with talking about some of the industry challenges. So unlike the centralized cloud, edges are diverse and they're distributed. And we'll talk about two types of edges. We have what's known as the network edge and what's known as the on-premises edge. And, the on-premises edge is located typically at an enterprise and services use cases like industrial, retail, healthcare, and so on. The network edge is located at various telco locations like the access edge, where you would find a 5G base station, or a near edge, where you would have a 5G user plane function, or a regional data center, where you would have a converged wireline and wireless interface, and even a next-gen central office. Now, what's unique about some of these edge locations is that these edge platforms not just run network functions, but also applications leveraging media and AI, leading to a converged edge. And therein lies a tremendous opportunity for a variety of players, including telcos, hyperscalers, system integrators, and independent software vendors. And they have the opportunity to consider a consistent cloud-native approach that can work across all of these edge locations, and most importantly, reduce the overall total cost of ownership. Now, that's great, but with it comes a lot of challenges. So let's talk through what some of those challenges are. First, you need to deliver a consistent and scalable platform across all of these different locations with different requirements. That's the first challenge. Secondly, you need to optimize a number of cloud-native frameworks that are out there today. And then finally, you must leverage a broad ecosystem of solutions and evolving standards for edge computing. So it is these opportunities and these challenges that really, motivates the development of OpenNESS.
So Prakash, tell us more about OpenNESS, what it is, what the value proposition is, and what are some of the various building blocks?
Absolutely. So OpenNESS is an edge computing toolkit that enables highly optimized and performant edge platforms to onboard applications and network functions with cloud-like agility on any underlying network. OpenNESS is a certified Kubernetes distribution for CNCF. It is modular. It can be consumed as a whole or as individual building blocks, and is built on a microservices-based architecture. The OpenNESS building blocks are built on a solid cloud-native foundation, including projects like Kubernetes, service mesh, telemetry. It uses frameworks like Helm, the Kubernetes operator framework, And these make it very easy to deploy openness on standard cloud-native frameworks based on Kubernetes. So openness offers a variety of key benefits. First is that it's optimized for edge KPIs like latency, quality of service, throughput, and so on. It is multi-location, multi-access, and also multi-cloud. Openness is delivered via use case specific reference architectures, which really make it easy to consume and help you accelerate time to market. It supports various industry standards like 3GPP, CNCF, ORAN, ETSI, and so on. And some of the key use cases openness addresses are 5G, cloud-native 5G radio access networks. It supports the 5G user plane function, various MEC applications, SD-WAN, but also traditional edge applications like AI and media. Now let's talk a little bit about the openness building blocks in a little bit more detail. Let's first talk about the multi-access networking building block. What that is a set of 3GPP compliant microservices that enable the deployment of an edge platform on a 5G, 3GPP compliant 5G network. Now, what's unique about what's happening in the standards is that 3GPP is not just defining frameworks for 5G, they've also started defining frameworks for Wi-Fi. So you can not just connect your 5G iPhone to your edge platform now, you can also connect over Wi-Fi, where the 5G core network essentially acts as an anchor point for your Wi-Fi devices. So this building block provides some of those microservices to connect both Wi-Fi as well as cellular networks like LTE and 5G. The next one we'll talk about is multi-cluster orchestration. So the idea here is that we do expect edge to be massively distributed in different types of clusters, sometimes even geographically distributed. The edge multi-cluster orchestrator building block essentially provides a number of very useful microservices that can be utilized to manage applications that are distributed across edge locations and are able to connect with each other. And that's where the edge-aware service mesh comes in, which is the next building block here, which again helps you discover and connect and establish east-west traffic between applications. And when you have these distributed edge clusters, the other key concept is you may deploy these edge clusters in completely different network contexts. And that's where the idea of a WAN overlay comes in, where you have a common view of different edge clusters from a networking standpoint. So the edge WAN overlay is another key building block that we enable. And then you start to get into interesting things like confidential computing. Here we are talking about protecting data in use at the edge, IP protection in multi-tenant type hosted environments. Resource management is another very interesting building block where you basically has all kinds of interesting Kubernetes extensions for things like node feature discovery, topology management, core pinning, and so on. Openness also supports a number of Kubernetes CNIs, including CNIs for Oven, for eBPF, SRIOV-based CNIs, and so on. And openness really is, provides the capability to, deploy edge using a number of different Intel platforms, not just CPUs, but also accelerators, VPUs, GPUs, FPGAs, and so on. And telemetry is another, interesting capability, not just platform level telemetry. We're also starting to see application level telemetry. Again, very interesting for, app developers. And then finally, the idea of power management. So there's a building block that we're offering called Green Edge, which is a collection of microservices and Kubernetes extensions for doing anything from managing power profiles to detecting hotspots on your network and so on. So let's look a little bit at how is openness actually delivered into the ecosystem. So all of these quite valuable building blocks that enable some of these use cases that we talked about can be accessed through two distributions. There is the open distribution, which is available under an Apache 2.0 license, and a Intel distribution of OpenNESS, which is available under a royalty-free Intel proprietary license and to be used on Intel products. So these two distributions enable partners to develop edge platforms with differentiated and compelling features depending on if you're using the open version as well as the Intel distribution. So, and you also have a number of these building blocks being commercialized by our ecosystem partners right here on Intel Network Builders, leveraging both of these distributions.
So Prakash, tell us more about the various customer personas and how do they consume openness?
Yeah, this is something that we are very, very tuned to because openness is intended for a variety of edge developers. So, and each type of developer will have different needs, different expectations. So we have devised different consumption models for various types of developers. The first one we'll talk about is something we call the Converged Edge Reference Architecture, or SERA. So SERA is a family of pre-integrated and readily deployable hardware, software reference architectures. And they're powered by OpenNESS, and they significantly accelerate your platform development. It includes a hardware specification, and there are a number of these SERAs, by the way. So it includes starting with the hardware specification, various software ingredients, of course, starting with OpenNESS, but not just OpenNESS. It also includes other frameworks from Intel like FlexRAM, the OpenVINO toolkit for AI, the OpenVisual Cloud toolkit for media, and so on. And it also includes a platform level configuration and a installation playbook for easy adoption and an experience kit with a lot of good collateral. These SERA platforms are location specific. So you'll have SERAs for on-premise, you'll have SERAs for access edge, you'll have SERAs for near edge. And they support a diverse set of workloads that will land on all of these different edge locations, and on a unified cloud native infrastructure, which is what OpenNESS is. And these various set of flavors, some of the ones that we've already made available in openness.org is the vRAN DU. We have one for the 5G UPF, for CDN, for Smart City, and so on. And it's a great starting point if you're looking to build a targeted edge platform. Now, the next, so that's one consumption model. The next consumption model, another way to consume OpenNESS, is through Intel's Edge Software Hub. So if you go to Intel's Edge Software Hub, you will see, you will be able to download a Converged Edge Insights package. So it's Insights as an AI. And so what this platform really includes are reference implementations for different types of use cases. And we use both OpenNESS as well as our OpenVINO AI toolkit to enable these use cases. So if you go there today, you will see a reference implementation for a smart city use case. In future, we'll be adding retail and industrial and so on, all kinds of use cases. Now, this is a great starting point, particular if you are a system integrator, right? If you're a system integrator and you're doing pathfinding efforts, then addressing customer RFQs, this would be a great starting point for you. Now, we don't stop there. In the Edge Software Hub, you will also see hardware dev kits. So the idea being that if you don't want to buy your own hardware and you want to just buy hardware just pre-installed with the software rather than buying hardware and software separately, you can go select one of these options from the Edge Software Hub to buy hardware dev kits that come pre-installed with these software packages that we just talked about. Again, a great developer toolkit for you to just kind of start your development just with hardware, software, fully integrated. Now, if you don't want to buy hardware, if you can't buy hardware, you would much rather work in your familiar DevOps environment, which might typically be in the cloud. Then we also offer software toolkits, and these software toolkits are deployed on cloud platforms. So, for example, we support software toolkits on Microsoft Azure, and if you have an Azure account, you can quite easily deploy this OpenNESS software toolkit. So this is another way for you to get started without acquiring hardware while still staying in your familiar DevOps environment in the cloud. So to summarize, Guy, your question around what are the different personas and how do you consume OpenNESS? So let's kind of summarize these. So first of all, there are multiple ways, like we discussed, to consume OpenNESS. If you're an infrastructure developer, by infrastructure I mean somebody building the platform level capability. So if you're an infrastructure developer, then you can consume OpenNESS as building blocks. You can go directly to GitHub, and these building blocks are delivered as Helm charts, as operators, Kubernetes operators, that you can consume them directly into your platform. So that's kind of the first way you consume it. Now, if you're an infrastructure developer, you have another option. You can also go and consume OpenNESS through the seras, right? So for example, if you're building infrastructure for a 5G base station, we have a SERA, which is a reference architecture specifically for the 5G base station, for the DU. Now that's another great way for you to consume OpenNESS building blocks. Just kind of get you started very quickly by starting with SERA. Now, if you want more package solutions, you have the other options we discussed. Now, in that case, you're typically more like a system integrator or you're an app developer. The package solutions that you can adopt are either the software packages available through the Edge Software Hub, or the hardware dev kits that come installed with the software packages, or you have the software dev kit that you can adopt into your cloud environment, your very familiar cloud environment, and do it that way. So again, multiple options if you're a developer, whether you're an infrastructure developer, a system integrator, an app developer, a lot of options. Now, finally, if you are an enterprise and you are looking for a completely hardened commercial hardware, Intel has an option for that too, and that is the Intel Smart Edge solution, which is a great solution based on some of these OpenNESS building blocks for private mobility. So that's an option for you as well to adopt the Intel Smart Edge solution.
Thank you, Prakash. Russel, can you walk us through one of the consumption models, the software dev kit?
Thanks, Guy and Prakash. Yeah, the demo has 4 primary steps. We're going to deploy our dev kit from GitHub, inspect the OpenNESS Kubernetes cluster, then review the discovered node features, and finally, I will deploy one of our Edge apps. This is actively being worked on and may look different when released. In the first step, I will deploy the OpenNESS from GitHub. The dev kit is made available as a README and an Azure template file on GitHub. We include some basic instructions and references. The Deploy to Azure button will launch the template into Azure, where I will specify a resource group, select an Azure location, select the flavor. Flavors are our predetermined deployment patterns for different use cases or edge locations. Initially, we will offer the minimal flavor, which includes our opinionated Kubernetes platform, our CNIs, primary building blocks to support app development, and optimization for OpenNESS. As we get feedback, we may offer other flavors through the dev kit. Then I will provide an SSH key, select the configuration number of nodes to deploy, and click to create. The deployment process takes about 30 minutes to complete. I will switch to one that's already waiting for us. And this next step of the demo, I will review the OpenNESS cluster. When the deployment completes, it generates outputs, including deployment results and access instructions. I will use this information to SSH into the controller node. Here I find the persisted Ansible inventory file and our installation log. I will now SSH into the Edge node. I have the shell windows labeled as controller node and Edge node. We generally refer to Kubernetes master nodes as controllers and Kubernetes worker nodes as edge nodes. I will retrieve the list of nodes and show that I'm connected to both the controller and edge nodes in their respective windows. Next, I will review the deployed pods. These include our primary building blocks that Prakash mentioned, our CNI, our resource management extensions, along with our telemetry services. Next, I will inspect a node to see the labels and annotations applied by our platform awareness extensions. I'll select the Edge node. Here we can see the detected node hardware features, instruction sets, and offload capabilities. If I had any hardware acceleration devices, those would be registered here as well. Within the edge environments, we may not have heterogeneous hardware. Labels for hardware features can be used to guide application deployment to the best hardware for a workload within a given location. In the final step of the demo, I will deploy one of our partner apps from the Intel Network Builder's Commercial Edge Apps portal. The Commercial Edge Apps portal is a resource for partners and customers to identify apps that have been optimized for OpenNESS or Intel Smart Edge to simplify Edge adoption. We are actively recruiting apps and solution vendors to participate. I will select Action's ZenDB. ZenDB is a secure and scalable database which provides SQL and NoSQL data storage to support service deployment. All of our Edge apps are delivered as Helm charts, which are templatized installation recipes and container images. I will clone our Edge apps repo, where we host the Helm charts onto the controller node. I will download the Action container images for ZenDB and the sample app onto the Edge node. I will load the container images into the Docker registry. Here I create the Zen namespace. Next, I deploy the Helm chart to load the application. Each publisher provides guidance on deploying and testing their app or solution. Following the guide, I will confirm that the Zen database deployment completed. Here we can see the database is running. Next, I will move on to the Zen sample app. Switch to the path where the Zen Helm chart is located. After updating the Helm dependencies, I will deploy their sample app through the same pattern which was used to load the ZenDB. The Zen app will then load content into the database. Using the guide from Action, I query to find the service location. Now that I have the port that the service is published on, I can browse to the controller node on this port. I will execute a select to demonstrate that the service is live. I can see the database was populated by the sample app. I can then go back to the remaining tasks Actian has outlined for configuring or testing their app. All of the resources deployed within the Zen namespace. The list of Helm traits shows that we just have the database and sample app deployed. Finally, they suggest that we sudo into the Actian Zen database pod and inspect the configuration. So I'll find the pod name. We'll enter the Actian Zen DB pod with bash. I see they suggest to sudo to Zen service account and export the current configuration and examine it. And here we have the running configuration for the database. If we wished, we could then uninstall the ZenDB and the sample app through Helm uninstall. This completes our dev kit demo. As you can see, it offers a simple but effective path to evaluate OpenNESS in order to test your applications or integrate your services with OpenNESS. Please reach out to the Intel network builders with any feedback, or if you have an app you wish to include in our Commercial Edge apps portal.
Thank you very much, Russell. Prakash, this OpenNESS dev kit sounds like a great tool for developers to get started with programming for the edge.
Guy, you're absolutely right. As Russell presented, what we saw was how by going to GitHub, a developer gets, just with a single click, the ability to launch a OpenNESS complete developer environment into their cloud account, their cloud context. Then going through a very curated configuration process. Russell showed how you're able to deploy an edge cluster, and then going through the Intel Network Builders commercial app portal, how you can actually deploy commercial applications in that environment. So with this experience, over a very short period of time, you can start to build a set of edge services by pulling together different applications together. Now, this is what this really means. We know that 5G is going to deliver a set of KPIs that will enable a completely new generation of apps that we can't even imagine today. Just like, maybe 10 years ago, we couldn't imagine Uber or TikTok, right? In the LTE generation. What has changed in the last 10 years is how big the app developer community has grown. And all these apps that were developed in the LTE generation were going device to cloud, whereas in the 5G generation, you're going to see device, edge, and cloud. And that's a big difference. These developers need technology. They need tools. They need to innovate faster than ever. And we sure plan to drive those innovations with technologies like OpenNESS.
Thank you, Prakash, and to you, Russell, for taking part in the session today and explaining more about the OpenNESS Edge Computing Toolkit. And don't forget to watch our next sessions in the Network at the Edge V Summit. We have a session on accelerating service innovation at the edge with Intel's converged edge reference architecture, and also one on how the Rural Cloud Initiative is spearheading the digital transformation of rural America. Goodbye for now.